So the first thing we want to take a look at is the difference between what are called scalars and what are called vectors. And they're both extremely important in physics, and it's equally important that you be familiar with what they are and the difference between them. So a scalar is something that has magnitude. And if you don't know what magnitude is, it's you can consider it something like strength or size. That's basically what it is. We'll do an example so you'll get the hang of it. A vector, on the other hand, well, it has a magnitude as well. So they both have a magnitude. But a vector not only has a magnitude, it has a direction. And that's very important. So a scalar, that's not how you spell direction. So a scalar has a magnitude, and a vector has a magnitude and a direction. So if that's a little unclear, let's do an example so you get the hang of it. So consider the sentence, Joe walked 5 meters. Okay, so simple sentence. So Joe is starting, let's say, here. And then he walks, let's say this is going to be 5 meters. I'm going to use M to abbreviate for meters. Now he's here. So what happened? Well, Joe walked 5 meters, and this 5 meters, this is a magnitude. This is a size. But we don't know if he walked 5 meters east, or if he walked 5 meters north, or if he walked 5 meters south, or northeast, or we don't know what direction he walked 5 meters. So in this sentence, 5 meters is just a magnitude. Now, if we change the sentence to say, Joe walked 5 meters east, or you can consider in this picture to the right. So now we still have our magnitude, right? But now we also have a direction. So we can consider this whole quantity a vector. This is now a vector because it has a magnitude, a size, and it has a direction. So let's go over some of the different kinds of magnitudes and vectors that we'll see, throughout physics. Let's talk about position. Position is an object's location relative to another object. Typically, we'll say the origin. And position is a vector quantity. And hopefully that'll make sense after we look at this example right here. So let's say this is my house. And we'll say it's at the origin. So 0, 0 if you want to do a coordinate system, but we don't really have to do that. And I am over here. I'm not that short, but bear with me. And the distance between me and my house is 5 meters. So my position in this situation right here would be 5 meters to the east. Then you could say of my house, but it's typically stated that the origin is what you're being relative to. So the to my house isn't really necessary. So I am 5 meters east, and so you can see that we have a magnitude right here, and we have a direction right here, and so this is a vector. The next thing I want to talk about is something called distance, and we'll scroll down this so we can get more room. So distance is the total amount traveled by an object. So let's think about what that means. The total amount traveled by an object. So you might be thinking, well, it doesn't matter if it travels 5 meters to the north, 5 meters to the east or west or anything like that. And so the total amount traveled by an object will be the same. So distance is a scalar quantity. Now, on the other hand, something. Now we'll go over something called displacement. Displacement is the net change in position. And as you might guess, displacement is a vector. And even if you didn't, we'll do an example right now, and so we'll get the hang of it. So let's say I start off here. Then I walk 4 meters to the east. Then I walk 3 meters north. So my first question is, what is my distance? Well, my distance is just the total amount traveled by me. So it's just going to be 4 plus 3 is 7 meters. So that is my distance. That is the distance I've traveled. Now, so the next question is, what is my displacement? Well, my displacement is going to be a little bit different. My displacement is the net change in my position. So if my position, we'll say right here, generally we pick where we start as the origin in most cases. So we can say that I went from 0, 0 to up here, which is going to be 4, 3 if we're in a coordinate system. So my displacement is going to be the length of this line that goes directly from where I started to where I end. And if you know a little bit about Pythagorean theorem, you know that this is 5 meters. So we can see that while the distance is 7 meters, the displacement, which is using the symbol S. So let's go over that real quick. S, and when this arrow on top means a vector. So this is the displacement vector, and my displacement is 5 meters. So we can quickly see how distance and displacement can be completely different things. So another example is, let's say we have a racetrack. I know they aren't really circular, but for right now, let's just assume that. And they're also even, but then again, I'm no artist. So this is the start line, and I run around the racetrack for a full lap. And we'll say that the racetrack is 100 meters long. So again, I'll ask the question, what is my distance? My distance is the total distance I traveled, and if the track is 100 meters long, that means my distance, which we'll abbreviate with D, I guess, is going to be 100 meters. And on the other hand, my displacement, well, what is my displacement? My displacement is the net change in my position. And if I started here, I ran around, all the way around the circle, and I landed back here. So there was no net change in my position. I finished exactly where I started. So the net change in my position is 0 meters. And so these are just a couple examples showing the difference between distance and displacement. And we'll do more and we'll get the hang of it. But this is just an introduction. I wanted to get you guys familiar with what they are. So see you next time.